Everyone, I'm Kamish from Jackson's Institute of Technology. I'm studying first year CSC department. Today I'm going to teach about side effects of high magnetic fields. In this topic we are going to see introduction, high magnetic field, facilities and stewardship ensures, side effects of high magnetic field, and conclusions and references. Introduction. The highest magnetic fields currently obtainable from permanent magnets are on the order of 2 Tesla. 1 Tesla, abbreviated T, is equal to 10,000 Gauss and is approximately 50,000 times the magnetic field of Earth at a latitude of 50 degree. Much higher fields can be produced by electromagnets. It is not known when the humans first noticed the attraction or repulsion between pieces of magnet materials. The first important devices depending on these forces was the magnetic compass, which is believed to have been invented in China around 200 BCE. However, the concept of a magnetic field as a description of the forces felt by magnetic objects and the laws that govern the interaction between magnetic fields and ordinary matters were first understood in the 19th century. An electric charge that is completely stationary should generate no magnetic field, nor would it feel a force due to magnetic field generated by other sources. However, according to the laws of quantum mechanics discovered in the early 20th century, electrons and nuclei are always in motion even at zero temperature, and electrons and most nuclei also have an internal rotational spin which can generate magnetic fields on the atomic scale. In most materials, the electron spins and other. Note, portion of this and the other section in the chapter have been extracted from National Research Council 2005 opportunities is in high magnetic field since the National Academic Press, Washington DC. High magnetic field. Magnetic fields are central to the operation of many devices crucial for the functioning of a modern society. For example, electric motors or generators of electrical power take advantage respectively of the force exerted by a magnetic field on a wire that carries an electric current and of the complementary process whereby electrons in a wire moving across a magnetic field will feel a force that can drive a current along the wire. Other devices such as readout heads in magnetic disk memories depend on magnetic field induced changes in the electrical resistance of certain materials which are used to sense the orientation of the microscopic magnetic domains that encode digital information on the disk. Magnetic resonance imaging, that is MRI device, which are now extensively used for medical applications, take advantage of different aspects of the interaction between field and matter. Here the combined effect of AC and DC magnetic field on the magnetic momentum of the spinning nuclei in the human body are used to obtain detailed information about the environment of the nuclei, which can distinguish between tissues of different types and can reveal changes due to pathological conditions. For motors and generators and many other electromechanical devices, increases in strength of magnetic field employed could lead to important improvements in performance. Here we can see researchers' reports resulting from projects using high field magnetics at the NHFML during the periods from 1995 to 2010, classified by a field of research. Source: National High Magnetic Field Laboratory. Magnets for high magnetic field. Scientists have been building electromagnets that delivers field of ever increasing strength since the 19th century. Two issues have had to be confronted at every step of the way. A major goals of research in high magnetic field is to learn how to create superconductors with higher critical fields and to learn how to make magnets out of these materials. However, the highest magnetic fields attained to date have been produced resistive magnets that are operated in a pulsed mode to minimize destructive heating effects. Facilities and stewardship issues. Magnets at the high field frontier are necessarily complex and expensive Both to construct and to operate high field magnets require a highly skilled staff to keep them running and to maintain the instruments that make them useful seriously. Here we can see an overview of magnetic fields available with different technologies, showing the corresponding rise times for the fields and the times during which experiments in these fields can be performed. So the graph courtesy of Jan Cornelis Mann, Radboud University, Nijmegen, the Netherlands. Side effects of high magnetic field. Potential health effect of static magnetic fields have received far less attention than, for example, power frequency and or radio frequency fields. Static fields are found in certain occupational settings. Example, in the aluminum and charcoal. In the aluminum and chloralkali industries, in ARC welding process and certain railway system, magnetic resonance imaging MRI for medical diagnosis and etc. Widespread concerns for health, the International EMF project and conclusions for the scientific research, as well as the effect of general health, effect of pregnancy outcome and cataracts. Here this is the summary of the magnetic field. Side effects of magnetic field. A wide range of environmental influences causes biological effects. Biological effects does not equal health hazards. Special research is needed to identify and measure health hazards. The conclusion part. There is controversy from the possible health effects on the static and yield of magnets for humans. It is difficult to prove independently whether harmful risk exists or not. Static field are expected to attract much more attention when high magnetic field technologies based mostly on superconductors like superconducting magnetic energy storage plants, SMEs, thermonuclear fusion reactors, and magnetically levitated trains, MAGLEV, begin to spread. Thank you everyone. Thank you for listening my class and on the video. Thank you guys.